Senior Product Manager at Tom Sawyer Software, and today we're going to be talking about graph intelligence. We'll be running a live Q&A at the end of the webinar. If you have any questions, please feel free during the webinar to go ahead and add your questions in the chat window, and we will answer them after the webinar. And if you miss anything, don't worry, we'll be sending a recording of the webinar as soon as it's available. So today we're going to be discussing the importance and benefits of graph intelligence and applying analytical and computational techniques to extract actionable insights from graphs. And we will also show several examples with Tom Sawyer Perspectives. So first, let's take just a couple of moments and discuss what Tom Sawyer Perspectives is. Tom Sawyer Perspectives is an SDK and low-code graph visualization and analysis development platform with integrated design and preview interfaces and extensive API libraries that allow developers to quickly create applications that intuitively solve big data problems. And so, how does Perspectives provide this? So first, Perspectives can connect to several types of data sources, including graph databases, relational databases such as Oracle, JSON or RESTful endpoints, and even Excel files or structured text files. And we're able to bring all of those data sources together, federated into the Tom Sawyer model. And once we do that, we're able to apply filters, rules, analysis, and create interactive data visualization views. So today we'll be taking a look at not only graph intelligence, but how you can use Tom Sawyer Perspectives in order to get the most results with graph intelligence. And specifically, today we're going to discuss uncovering hidden patterns and relationships with advanced visualization and analytics, using interactive data navigation to discover the wealth of information embedded in your graph data, understanding when key events occur through timeline visualizations, and also how to communicate key findings to decision makers and stakeholders. All right. So first, we're going to have an overview of graph intelligence and what is graph intelligence. So graph intelligence can help you discover areas of interest in data, optimize complex systems or processes, and deliver key information to stakeholders and decision makers in a timely manner. And what is graph intelligence? The application of analytical and computational techniques to extract insights from graph data structures. And it also involves analyzing relationships and patterns where entities are represented as nodes and their connections are represented as edges. Graph intelligence also leverages algorithms to understand complex interdependencies, identify clusters, and also predict trends in network data. So overall, graph intelligence offers deeper insights than traditional linear data analysis methods. So graph intelligence can enable intelligence analysts to take actions on their data by helping them to uncover hidden patterns, discover key relationships, enhance decision-making, predict trends and behaviors, optimize networks, and detect anomalies. So how do you use graph intelligence? And so today we're going to look at several examples of how to use the Tom Sawyer Perspectives Graph Intelligence platform. And in order to best use it, first you need to have a clear use case. Then you need to identify and gather the various sources of data for analysis. And as we discussed earlier with perspectives, you're able to federate across many data sources, even different types of data sources. And once you have your data federated, you can use effective graph visualization tools to interpret, navigate, and communicate insights. Also, it's important to understand that you need to apply the appropriate set of graph intelligence analytics because not every type of analysis is appropriate for every type of use case. So you need to use the ones that are correct for your use case. And you use the graph intelligence to focus on the most relevant data that you have. So as we mentioned earlier, perspectives can federate data from across many sources. And so we include several of those sources here. So you have graph databases such as Neo4j, Amazon Neptune, Janus Graph, but we also can work with relational databases such as Oracle or MySQL or Postgres. And then we can work with other types of data formats, your JSON, RESTful endpoints, XML, RDF, and structured text. So how do you apply graph intelligence? So first of all, you need to have a good set of capabilities that you can apply to your data. And today we're going to look at these types of capabilities: graph layout, graph analytics, interactive query builder, the ability to load neighbors so you can incrementally bring related information into your visualizations, using timelines so you can understand what has happened and when has happened, uh, filters, applying swim lanes, and then using view layout to bring all of it together to create a dashboard so you can effectively communicate key results to stakeholders and decision makers. Okay, so now we're going to move on to some demonstrations of these key capabilities that we just discussed. So first, we're going to start with graph layout. So the graph layout is the way that you visualize the graph. Oops, sorry. The graph visualization is how you lay out the nodes and the edges in your visualization. Where do the nodes go? Where do the edges go? And there's many different ways to do this. So here we have an example computer network, and we have several different types of visualizations. So first we have the orthogonal layout, where your edges are going to be predominantly horizontal and vertical. Then we have bundle layout. And by the way, this is the same graph, just with a different layout style. This is bundle layout where the edges are intelligently grouped together so that you can put a large, dense graph into a smaller space. Then you have circular layout where we take the natural um, clusters that occur in the topologies of the graph, and we put those onto a circle. And we have hierarchical layout, so we can see flows and dependencies. And then we have symmetric layout, so that we can see natural symmetries in the visualizations. Okay. And so we have, of course, many more details we could discuss about graph visualization and graph layout alone. And so we have many videos on our YouTube channel. I encourage you to go take a look at those. And we go into deep details on each one of these layout styles. Now, I'm going to go back here to the hierarchical layout, and I want to show you something special about the Tom Sawyer layout. Not only do we have these global graph layouts, we also have incremental layout. So for example, let's zoom in here. And we're going to select one of these nodes. And let's say that we want this node to be a little further to the left. So I can pick it up and I can drag it over, and then I can select the incremental layout option, and it will clean up the drawing for us. Okay. All right, so let's go ahead and move on to our next graph intelligence capability, which is graph analytics. So Perspectives has a graph analytics suite that provides many intelligence algorithms that can be run in real time through automatic background processes or interactively by users. So we're going to take a brief look here, and we're going to use another example application that comes with Perspectives, and this is for a microwave antenna communications network. And so we have a couple of different types of analysis that we can run. So we're going to take a look at a couple of those here today. Oh, and you can see here another nice example of our orthogonal layout. I will zoom in here. And you can see how the placement of the nodes and the edges and the labels on the nodes and the edges are all placed very carefully. And this occurs with our advanced layout algorithms. You also can see how we provide visualizations of the jump overs, or where the crossings occur in this layout. So this type of layout capability is unparalleled out in the industry. Tom Sawyer is the clear leader in having these advanced graph visualizations. Okay, so now we're going to zoom out here, and we're going to find a shortest path in our system because we want to know what's going to be the quickest way for two of these antennas to communicate with each other. So I'm going to select this node, and I'm going to set it as the start, and I'm going to select this node over here, and I'm going to select the end. And I'm going to ask Perspectives to run a shortest path analysis. And so it does that, and you can see how Perspectives not only found the shortest path, but also visualized it very clearly for us. So it showed us that shortest path in a different color, and it grayed out all the other edges interactively so we can very quickly see what is the shortest path between these two key components. So now we're going to run a different kind of analysis. So I'm going to clear those shortest path results out. And now we want to know more about what's happening in our network at a high level. So I'm going to apply a clustering analysis. And you'll see how the colors of the nodes changed very quickly. So what happened here? So we just applied, with Perspectives, we applied a data-driven analysis to show us which parts of the network are more closely related to each other. So those different node colors tell us that those elements belong together. But we're going to take this one step further. We're going to take all of these nodes of the same color and put them into a nested drawing. So now we're going to apply complexity management to our graph visualization. So I'm going to come over here to settings, and I'm going to say group by cluster. We're going to apply a updated orthogonal layout. And you'll see that all of the nodes that are of the same color are in their own nested drawing. So let's zoom in over here. And so you can see how the nodes are separated from each other, and they are within their own nested drawing. So you have a graph inside a node. And At the same time, you can see details. Let me zoom in a little bit further over here. Even though we have these nested structures that help us manage the complexity of our graph, we do not lose any detail. We can still see what this element is connected to, for example. So we can tell, oh, it is related over here. We have not lost any of the detailed information. And then, of course, you see the advanced orthogonal layout. We still have the careful placement of our nodes, our edges, our labels. We have the visualizations of the jump overs. We still have all of that information. Okay, but let's say that we want to abstract this a little bit further. We don't want to see all the details. We just want to see the high-level view of the network. So we can collapse all of those nested drawings. And so all of those nested drawings are now collapsed into their parent node. And we are looking at the high level or the backbone of our communication network. So if we want, we can explore. We can selectively expand some of the drawings so we can see the particular details that we need to see that time, and also have an idea of what's happening at the high level of the system. Okay, very good. All right, so now we're going to go on to our next graph intelligence capability, and that is the query builder. I have another screen over here ready for us. So what is the query builder? So Perspectives provides a advanced visual query builder. Open that here. And what does this do? This query builder allows you to search for matching patterns in your graph data in order to load more data into your visualizations without the need to know the Gremlin or Cipher query languages. So let's see how this works. Okay, so first we're going to start with a very simple pattern. And this is an example application which is exploring a graph database that has information about movies and the actors and directors associated with them. So first, let's just do a very simple query. We want to find actors that have been in a movie. So give me these actors in the movies that they have been. And so we see here our graph pattern. So we have the person, acts in, movie. So by the way, where does this come from? This comes from the schema of the graph database itself. So you customize, or you can use this graph query builder just based on the query of the schema of your data. You don't have to do anything in particular with the query builder. It knows automatically to look at the schema, and it allows you to make the appropriate queries that you need. And so again, as I mentioned, you do not need to know the Gremlin or Cipher query language in order to use this. If you are curious and you want to see the query that's going to be run, you can do a show query. So you can see here a detailed Cipher query. So we just saved ourselves a lot of trouble by not having to figure out how to create this query, because we don't have to do this. We don't have to look at this query at all. All that we need to do is do this simple graph pattern that we just showed here. Okay, so now let's go ahead and apply the query builder and see results. So I'm going to click OK. And so now we just interactively went to our graph database and we found some results on our actors and the movies that we can be in. So let's see, let's zoom a little bit. And you'll see we have different kinds of graphics for the movies and the actors in the movie as well. And we can very clearly see that, oh, Harrison Ford, he was in two of the movies that we're looking at here. And it's just very obvious by looking at the graph visualization. Okay, so now let's go and update our query a little bit. Let's see if we can find out something a little bit more interesting. Okay, so now we want to find um, uh, people that both acted in and directed the same movie. So let's update our pattern. So I select both the person and the movie, and I go over here and I click in directed. And so our graph pattern updated. So we're now looking for a person who both acted in and directed a movie. And we click OK. And now we see even more results. So let's go in and we're going to take a look. Oops, let's zoom in over here. Oh, and so we can see people that have done both acting and directing in the movies very, very quickly. All right, so now let's go ahead and start fresh and run another query. So I'm going to select everything. I'm going to delete it from our drawing view, and we're going to go back to our query builder. And let's go ahead and start fresh here as well. So I'm going to delete. And now we want to find actors and directors who work together in movies. So first of all, we're going to again start with this person who acted in a movie. And now we want to add that second person because we want to look for directors that work together with this actor in a particular movie. Okay, so we're going to select and we're going to say directed. So now we have one movie and we're getting information about the actors in them and also the people that directed that same movie. Okay, so that's a pretty interesting pattern. We can find out people who've worked together. But let's take it one more step. Let's find people that have worked together in at least two movies. So I'm going to select a movie and we'll again add the acted in and then again we want the director pair as well. And let's do our little fresh layout. Okay, so now we are looking for people that have worked together in at least two movies as actor and director. And we press OK. And so now we have the relevant results for what it is that we need to find in the data. So let's zoom in over here. And so we found a particular director who has worked on directing several movies and looks like they work with several of the actors in several of the movies as well. So it looks like information that we have a director who prefers particular actors and particular pairs of actors. Okay, so related to the query builder is the load neighbors capability so that we can interactively load related data into our visualizations. So we have a little example of that as well. And so I am going to show you here on our slide. Okay, so now here we have a different example, and we are looking at a music database in this example. And so you can see here that we have loaded some data already. And what we want to do is we want to load some related elements. But we want them to fit a particular pattern. So what pattern are we looking for? So here you'll see that we have some blue nodes and we have some orange nodes. The orange nodes are singers, artists. And the blue notes are the songs that they have written or performed, depending on, of course, the data. So we want to know that we are going to select some songs, and we want to know which songs followed those. But we don't want just all the songs that followed the ones that we selected. We want to know the ones that have had a lot of performances. How many performances? At least 100. So in other words, we're going to select some items and we're going to say, show me the songs that followed that have had at least 100 performances. So let's see how we do that. Okay, so we're going to select all of our items in the visualization and we're going to open our load neighbors capability. And what this is telling us right here is that we have selected 3 artists and 94 songs. So as we mentioned before, what we want to do is we want to search for songs. So we are going to go ahead and we're going to select this artist part of our graph pattern and we're going to remove it because right now we're just concerned about songs. Okay, so we have 94 songs selected and we're looking for more songs that followed those 94 songs in time. But as we talked about earlier, we don't want just all the songs. We want the ones that have had a lot of performances. So now we're going to add a condition. Okay, so let's keep going here. So we add a new condition where the number of performances is greater than 100. And we click OK. So there is the graph pattern that we have. We want to find songs that have followed the songs that we selected, but with the condition that there have been at least 100 performances. Okay, now let's press OK and see results. And now we have loaded the relevant related data into our visualization. Okay, very good. All right, so now we're going to move on to our next graph intelligence capability, which is about time. So there are many different ways to understand what's going on in our graph over time. And we're going to show several of those ways. So Perspectives has a timeline view, and it's going to help the analysts understand where and when key events occurred. So what we just saw here was where we saw the graph change over time in front of our eyes. It was as the blue bar moved across the bottom of the screen here, we could see the graph change and new nodes and edges being added. So sometimes that's what we need to know. We need to know what's been added to our system or what's been added to our network over time. So that's the first type of visualization for graphs over time. But sometimes you need something different. Sometimes you need to know the most recent data. So what we just looked at, we're adding data. Sometimes you need to take data away. You need to find out, well, what is aged out? If it's aged out, remove it from our visualization. I just want to see the most recent information. So we're going to show that here. We're going to remove old data. And you'll see the graph update and nodes and edges disappear as we continue. So in Perspectives, we call this play right. So this is when you're removing information from the structure. The first one we showed you is called play left. We also have a capability called play both. And when do you use play both? When you want to see a snapshot, what happens on a particular day or a particular week, or you can even say what happened in a particular minute. And for example, whichever unit of time that you need, you set up your timeline view to show that. So here in this case, we want to see actions and events that happen on a particular day. So let's go ahead and start the animation. Again, this is called play both in our timeline. So our graph visualization will show us what happened on day 1, day 2, day 3, day 4, and so on. So we just discussed these 3 different ways that you can see trends in your data over time. What's new, what's most recent, and a snapshot of what happened in a particular time. Okay, now there's a 4th way to visualize what has happened over time. The 3 examples that we just looked at show the graph changing in front of our eyes for a particular unit of time. But let's say that you don't want the graph to change in front of your eyes. You want to see everything all at once, but you still want to have an idea what happened when. So we have a timeline layout, and we show an example of that here. So the timeline layout emphasizes the chronological order of the nodes that represent events by arranging them from left to right. And you can see all of the nodes at once. So for example, what is happening here? First of all, we have 2 color nodes. The blue nodes are actors, and I don't mean movie actors. I mean causes of a particular event, for example. And the yellow nodes are the events. So here in the first column, we have the relevant causes of things in our system. And we can see with the edges that they caused a particular event, like this element right here, this caused a particular event to occur. You'll also notice that these yellow nodes are in columns. That's because these events happened in a particular unit of time. So again, you get to use a unit of time that you need. But let's say that these are days. So we can see the events that happen on day 1 and day 2 and day 3 and so on. And the edges, they represent who caused the event or what element in your system caused an event. And was it in response to a different event. So we have our actors or our causes of events, then we have our events, and then the layout tells us at what time period did they occur and how they related to each other. Okay, very good. We're going to move into our next type of graph intelligence capability, and that's for filters, because sometimes you don't need to see everything all at the same time. So we're looking here at an example crime network. So over here on the left side, we have information about the types of incidents and where they occurred. We have information or selections of the different precincts where these crimes occurred. Over here, we have the crime network. So the people that work together on certain crimes. So each node is a criminal, and there's an edge between them if they committed a crime together. Then we have the map view, so we can see where these crimes occurred. And we also have information here in charts to show us a summary of the events that have occurred. You also may recognize this here. That is the timeline that we were just looking at. So we can see, not only what happened, but where and when it happened. And we have some summary charts as well, telling us about what kinds of things are happening where at a high level. And these views are synchronized. So if you do an update or if you select items in one view, you'll also be shown that information in the related views as well. And that is part of the Perspectives platform, that the views are synchronized with each other. And so right now we're going to focus in on filters. And so a filter is a way to focus on certain key results by showing just those views, those in your views. So we are going to deselect one of these precincts, and we'll see how automatically the visualization views are going to be updated. So here's the before, and in a moment, this will change when we update our filter. So we're going to go and we're going to deselect the South Precinct. And you can see how the views updated. There. Oh, so you can see how our social network is smaller. Our map view is also updated. You see results have been removed. And then our charts look quite a bit different. As you can see, the information about that precinct, the South Precinct, um, has been removed from the chart views as well. All right. Okay, so now we're going to go on to our next capability, which is swim lanes. So we have an example of that over here. We are going to take a look at our fraud demo. And many of the demos that we're looking at today are available on the tomsawyer.com website. So you can go and use these yourself as well. So what have we done here in this example application? We have run some background analytics on credit card data and associated accounts and other attributes. And we are looking for something suspicious. We are looking for potential fraud rings. So before today, we ran some background analytics and we found some potential fraud rings. And they're over here in our tree view on the left side. And so we want to know some more information about some of these potential fraud rings and investigate and see if there are real crime rings. So we're going to select one of these and we're going to open the case. And on the right side here, we see that potential fraud ring. So we're looking at orthogonal layout. Let's go ahead and apply hierarchical layout. So we can see, we have some accounts, we have a phone number, we have a location, but it would be nice if we had an easier way to see what kind of information do we have quickly. So I'm going to apply swim lanes. And so now that same graph visualization is going to be categorized for us. So we very, very quickly see, oh, we have one email address. We only have one phone number, but we have 4 accounts using those. And we have these 5 suspicious accounts. And oh, yeah, some of them have the same physical address. So that's curious. So what's going on there? So let's take one of these and say, we want to investigate more. What's happened? So we are going to select it, right click and say load neighbors. So now it's going to load the transactions associated with that account. And so now, as you can see here, the visualization automatically created a new swim lane for me, and it showed me what transactions are associated with that account. And so you can interactively explore these fraud rings and find out more information if you need to, like what transactions are associated with this account. Oh, and if you want to, you can continue to load neighbors. Where do those transactions take place and such. So that is one-dimensional swim lanes. We also have two-dimensional swim lanes in perspectives. And so here's an example here with the two-dimensional swim lanes. So we're looking at a subset of that microwave antenna communications network that we were looking at just a little bit earlier. And we have put some of that information into this two-dimensional swim lane visualization. So what do we have here? So we have in the columns the particular vendors or the makers of the antenna. And here in the rows, we have antenna size, the physical size. How many meters wide is it? And so let's say that we have a particular vendor that has had a recall. So we need to very quickly determine what part of our communications network has been affected. and which other parts of our network are connected to it. So let's say that it is this vendor and this particular antenna size. So very, very quickly, we were able to identify which elements in our system have had a recall and they need to be updated in order to keep our system in good shape. So first of all, we're able to identify which elements have to have an update. And then we can also tell what other side effects are we going to have in our system. We can say, oh, well, we have these two elements over here, and they're connected to everything associated with a recall. So we might have a slowdown in the related parts of the network as well. So the two-dimensional swim lanes on top of um, uh, the high quality advanced graph visualization, we're also able to add 2 layers of categorization so that we can find that information that we need quickly and also communicate it to key people. All right. And our last capability that we're going to discuss today that supports graph intelligence is our view layout. So we talked about many different different type of different types of data visualization views that we have, but we need to organize them well. And so in Perspectives Designer, we have an interactive view layout capability. So here we have an example of, again, the crime network example that we were just looking at a few minutes ago. So we can see and choose where we have certain visualization views. We get to pick, and it is a point and click interface, and we can set the style and organization of our dashboard. So here's the before in our view layout, and here's the result. This is what our dashboard looks like. And just as a quick view here, I have Perspectives pulled up. So this is our low code development platform, which works with our SDK. So is a core part of Perspectives right here. And here we're looking at the view layout for one of the applications that we looked at today. And you're able to move your views around. You can add new views here as well by just doing some pointing and clicking and adding views where you need them. So I just added a new table in just those few steps, and we're able to see our web previewer right away. So thank you for joining us in our webinar today. We covered quite a few topics as part of graph intelligence. So first we had an overview of graph intelligence, and then we used several examples to show us how to use graph intelligence to transform your data into advanced insights.